10.3, where we're looking at dot products and that type of stuff. So anyway, we kind of went through the always, sometimes, or never deal. But we did have, I started talking about this yesterday, but we had a theorem. And this theorem said, hey, if we have angles here, so if we got the x-axis coming out, the y-axis to the right, and the z-axis up. Anyway, if we have two vectors, so I'll just use different colors here. So let's say here's p vector, and then we have a different vector. Let's just say over here we'll call that q vector. Try and match kind of the picture in the notes. Then we have an angle in between the vectors. So let's just use black for this angle. If this angle in between, if we connect that, is theta, then we said yesterday that 0 degrees is less than or equal to theta is less than or equal to 180 degrees. Of course, we don't usually do that. We use radians, right? So that's less than or equal to pi. So I was confused by that. But anyway, so theta is the angle between P and Q, the shortest angle between, smallest angle. So anyway, we do have a theorem, proven fact here, based on that. And if A vector and B vector have theta in between, of course I could use P and Q vector.
Okay, all I can see is that.
Really?
Mm-hmm.
Well, that's weird. Is it just slow?
It's not updating. Maybe it's just mine. I don't know.
Well, it says I'm connected to the internet. So,
I'm refreshing it.
okay.
Okay, now it's good.
All right. So P vector dot Q vector would equal, so that's a dot product. Okay, so that's a scalar, right? So this is going to equal the norm of P vector times the norm of Q vector times the cosine of theta. So, you know, and then what's nice about this is if you wanted to solve that for cosine of theta, then, so if we have our two vectors and you're wondering about the angle in between, we can use this theorem and say, hey, cosine theta is P vector dot Q vector divided by norm of P vector times norm of Q vector. All right, so that's a nice way to be able to come up with our theta here, or cosine of theta, and then take the inverse cosine to get theta. So that's a nice result. Of course, in the notes I use A and B. We could actually prove this using law of cosines. Is that in your notes on the middle of page 2.5 or 10.5? Sorry. Do I have a proof with law of cosines on that? Yeah, to the right of this theorem, I proved it, but if not, I'll do it now.
Yeah, there's proof.
Okay. So basically, man, where drawing? Here we go. But if I have a triangle here, and this is an angle, here's my angle theta here. If this is side A and this is side B, and this is side C, we know that law of cosines, we have that C squared equals A squared plus B squared. You know, if that's a 90-degree angle, then where C is a hypotenuse, we're just done here. But when it's not 90 degrees, it's minus 2AB cosine theta. Okay, so this is the law of cosines that we have here. And really what we have is we're redrawing this picture with this angle theta here. And of course, the length of this side would be, I used A's and B's here. So instead of P and Q, if I used A and B for my vectors, that's the norm of B vector. This is the norm of A vector. And of course, this connection here is b vector minus a vector, depending on which direction you're going. But if I take the size of it, you know, we can do that. So remember, minus a vector goes backwards, you know, and then we can connect it, etc. But anyway, we went through that before. So really what we can say here then is what we've got c. So this is the norm of b vector minus a vector, and so we can plug that stuff in. So c equals that, and you know, a equals this and b equals that, and then we use another theorem that we had too that talks about the norm of b vector minus a vector. So anyway, that's kind of how that proof goes. But so let's just look at a quick example. And if we want to find theta between two angles, let's just do a different one than is in your notes, hopefully. So find theta between let's just do two different vectors. Let's do 1, 4, -3, and 2, 5. Let's do -2, 5, 1. Okay, so we want to find that angle theta between. Well, first thing we're going to do, so this is, you know, we call it p vector and q vector. We'll just call it a vector and b vector. So first thing I need to do is find what a vector dot b vector is. Once again, set these on top of each other and multiply the components and add the results. So 1 times -2 is -2, plus 4 times 5 is 20, plus -1 times 3 is -3. So that's -5 plus 20 is 15. So a dot b is 15. And then we can do so like if this is a vector and b vector. Okay, so the norm of a vector and the norm of b vector. And so the sum of the squares of the components, square root of that, right? So what'd you get? Square root of 30, which doesn't really simplify down. There's no perfect square in there because that's 2 times 3 times 5. So anyway, so we got these. So what do we know? We can use these things here to figure out that the cosine of theta is going to be, once again, it's a dot b divided by a vector dot b vector, sorry, divided by norm of a, norm of b, norm of a vector, norm of b vector. Whoa, just need 2 of those. Anyway, so what is that? I gotta get, I'm gonna erase. So we had that. It doesn't want to erase. So hopefully it lets me draw. What's this equal? Cosine theta? Nope. All right, so we got that 15 square root of 26 and 30. You gonna remember those? All right, and then we can, so it'd be 2 times 13 and 2 times 15, so it'd be, yeah, whatever.
26 times the square root.
No, you're fine. Yeah, I mean, we're gonna end up being able to take a 2 out. It'll end up being 13 times 15. Because there's a square root of 2 times square root of 2. So it's going to be 2 times the square root of 195. Whoa. Oh, is that 780? Okay. Which is 2 times square root of 195. That's not really working for you? On the bottom. And then 15's on top yet. We'd actually, Yeah. So anyway, that's cosine theta. And then if we divide that, so 15 divided by that quantity, 2 times 195 square root, it's about 0.537. And I'm in degree mode. So you got to pay attention to what your calculator's saying, but 0.537. So if I take, if I'm in degree mode and I take the inverse cosine, I get about 57.5 degrees. So theta, not cosine theta, theta. Like if are you doing inverse cosine? Sorry, I'm not trying to, I have control issues.
Equals what?
57, approximately 57.5 degrees. Yep. So anyway, and can I just change this over to radians, which is about 1.0 radians. Is that, is that right? Radians. Well, and then, yeah, I divide that by pi. So it's like about 0.32 times pi radians. So it doesn't matter. Anyway, but that's the 57.5 is degrees. So as long as you're matching odd answers in the book,